leads to things like weakness, mobility issues, and over time, osteoporosis, sarcopenia, and all the other things that you don't want if you're with me on living to at least 100 people. MitoPure offers the benefits of exercise specifically for your muscles in a pill. It builds muscles without changing your workout routine by targeting those muscles at the cellular level. Multiple studies show MitoPure increases muscle strength by 12.
twisted and tied. Alright. Oh no. Alright. Why is it still doing it? What the heck? Okay, maybe it's fine. Oh, I know what's going on. 1 second. 1 silly second. You need to do that. That. I'll hide you. And mute you. Okay. Alright, hopefully you can hear me now. Hello, Farax. Hello. Yeah, how is everyone doing? Oh, hopefully that's fine. I'm doing all right. I'm excited that I get to actually do this. It'll be fun. And this time I actually am modestly prepared. Hello, Astral. Hello, Astral. Whoa. This time I'm a little bit more prepared than normal, which I know isn't saying much, given I'm usually not prepared at all. But I have a little explanation-y bit, yeah, to explain what's going on. So that'll be, that's what you see. Because that is today's stream. You all know. I hope you all know that H2O is water. If not, then it is. Same. Nice to hear. Great. Yeah, like H2O is water. I did actually do this little meme. I literally did this. I accidentally wrote H2O as HO2, and I will never live that down. But I can do my best to atone for my sins, because it turns out HO2 is a real thing. It doesn't quite make sense. We'll get to that in a little bit, but it is in fact a real thing. And so that's the plan for this stream, is to show that this cool thing that exists, show some fun fun chemistry, which does actually have some applications in like cleaning up oil spills and stuff, which is really cool. Be right back. All right. Yeah, that's basically how this started. Was I typoed water. I made the stupidest typo you can in the world of chemistry, and I was like, wait a minute, that's a real thing. That's a real thing. So let me. Oh no, my computer's being silly again. There we go. Silly, silly computer. All right. So, yes, I did do this. I wrote water as HO2, but if you strain your eyes, peer deeper into the abyss, and really, really try to imagine it, it turns out it's a thing. It turns out HO2 is a real thing. It's called hydroperoxyl. And oh, what's this little dot here? We'll get to that. Those of you who know what this means know what the dot means. We'll get to that. It does not. It's not like it is in music. It does not mean that it's 1.5 times the length of the beat. But yeah, that's what we're talking about. We're talking about hydroperoxyl and what the heck it is. And for that, chapter 1. What the fuck is hydroperoxyl? Hydroperoxyl is a radical, and that of course begs the question: what is a radical? So that's what the dot means, or the little dot after HO2. Tells us it's a radical. But what the frick is a radical? Well, let's start with, the basic normal bonding, normal molecules, right? You have, atoms, and they have like a valence shell is their outermost shell, and they've got some electrons in them, but they're not always full. Unless they're noble gases, then they're full. Then they can come together and share pairs of electrons in order to have covalent bonding, right? So they decide to share these pairs, they're bonded together, you get water. Yay, everyone's happening. But what if everyone's happy? But what if we only had an O and an H? What if we only had, oxygen and hydrogen? What if it was just like this? Well, there's still this extra spot. There's, still this extra spot here. And we could add in an extra electron to the system, which would, resolve the valence shell. We would now have an extra electron in the valence shell. And because we added an extra electron to the system, it is now going to be negatively charged. And this is called the hydroxide ion. But what if we didn't? What if we didn't? What if we had a molecule with unpaired electrons, unpaired valence electrons? That's what a radical is. And as you might guess from the fact that they're weird and would really, really like to have another electron, they're generally really, really reactive. They are the like malevolent agents of chaos and will just attach and screw up everything they can get their grubby hands on. But the radicals are formed a lot. We'll get into this in a little bit. But they're formed a lot in the atmosphere. So a lot of like atmospheric chemistry deals with radicals. And like, lots of the radicals are all over chemistry, but we'll get there. All right. Now I am prepared. I have more slides than this. No, respond. Why is my computer? There we go. Oh, okay. No, too far. No, spoilers. Don't look. Don't look at the spoilers. What is going on? Do I need to plug my computer in for it to not be sad? What are you doing? Don't look. These are spoilers. Spoilers. Don't look. Okay, there we go. We made it back. Okay, yes. Yes, this is a radical, and in this case, it's called the hydroxyl radical. So hydroxide is the ion, which is when we have an extra electron. Hydroxyl is the radical with an unpaired valence electron, and it would very, very much like to have an electron there. It's not, the radicals are quite unstable. All right, and this is hydroperoxyl. It's more or less the same thing, just with an extra oxygen tacked onto it. What does it do? What is it used for? It actually shows up in something useful, and we'll get there eventually, and then we'll get to do the little demo thing, which I think will be fun, and involves highlighters. Yeah. So that's the idea. I'm looking at the spoilers. No, don't look at the spoilers. I hope you didn't look at the spoilers. It's all right. It's all right. We'll get there. All right. Here's another radical. This is the chlorine radical, right? You can see this is just chlorine by itself, has an unpaired valence electron. What about oxygen? Like O2, the oxygen that's just around in everywhere, that's like 20% of the air or something. Is oxygen a radical? I mean, it doesn't really make sense, but if you draw it like this, and then you have a bond here, oxygen could this be oxygen? What if oxygen is a diradical? So this is a very strange molecule, which is kind of a radical, but kind of not. where you have the molecule as a whole has an even number of electrons, but the atoms within it have unpaired valence electrons. It's very weird. It turns out that oxygen is a diradical, yes, but this picture is wrong. Because if you've ever seen a little diagram of oxygen, you'll know that there's a double bond, right? We only have one bonding pair here. Oxygen is actually double bonded. So what's going on here? Have I been lying to you? Is oxygen not actually this weird diradical? That would make sense, but no, oxygen actually looks like this. The O2 molecule is just incredibly screwed up, and it's very weird. Not only is it this weird diradical thing where the molecule as a whole doesn't have unpaired electrons, but both of the atoms within it do. It has like 3 electron bonds. It has 2 3-electron bonds. That's the double bond. Oxygen is cursed. It's just always wild to me that like this incredibly cursed, non-classical bonding and this bizarre diradical, like the fact that this super weird molecule, you would think this is some weird thing you make like in a lab with a bunch of fancy equipment. No, it's oxygen. It's like one of the most common molecules. It's just all around us. It's crazy. It's wild. It's wild. It's wild. All right. So radicals do seem cool because they are cool, but like, what can they do? Can they do anything? Can they do anything? They can do things. All right. So we begin with our wildly screwed up cursed oxygen, and we shoot it with frickin' UV light because I mentioned atmospheric chemistry. We're in the atmosphere, and there's lots of UV, upper atmosphere, lots of UVC radiation that can blast apart to create 2 radicals. So this is an initiation reaction, is when you start with something that, and again, this is kind of a bad example because oxygen's this weird diradical thing, but the point is you take something where the molecule as a whole doesn't have unpaired electrons, you blast it with friggin' radiation or something, and now you have something that does have unpaired electrons. Again, oxygen's kind of a weird case, but just go with it. So, what happens when I've got this oxygen and when I've got an oxygen radical and an oxygen molecule? So oxygen, do I have a laser pointer? Can I get the laser pointer? I can get the laser pointer. Woohoo! Yeah! What happens if I have an oxygen radical and an oxygen molecule? Well, remember, the radical wants to link up with something, and it does. It forms ozone. So this is ozone. This is how the ozone layer is formed, right? It's oxygen radicals meeting with oxygen molecules, and this is not really ozone. Ozone actually alternates like back and forth between these 2 forms. It's resonance. For our purposes, resonance doesn't matter so much. I just wanted to put it here to clarify. Now, what happens if we get chlorine radicals in the atmosphere? So not chlorine like molecules, not like Cl2, but chlorine radicals, which if you remember, were back when we used CFCs and stuff, and those were not so friendly to the ozone layer, what was actually going on? Well, we'll find out, because what happened is in the atmosphere, under the barrage of UVC radiation, that would the CFCs, the chlorofluorocarbons, as well as like other stuff like CBFCs, because bromine is actually way worse, but whatever. When we put all this junk into the atmosphere, the UVC radiation would break it down into these chlorine radicals, these evil chlorine radicals. I'm getting ahead of myself. I haven't shown you that they're evil yet. You can guess they're evil, but ozone arrives. What happens when ozone meets these chlorine radicals? It absorbs them. So now, this is a propagation reaction is technically the term, right? Because the radical this is still a radical. We've gone from radical to radical, but it's now messed up something else, right? So we've got our oxygen, and now we have this oxychloral radical. I don't actually know what it's called, but OCl, and it's a radical. Now, we've destroyed some ozone, but remember how we've destroyed ozone, which is bad, but it actually gets even worse, because remember, we need oxygen radicals to even make ozone in the first place. And what happens when our these oxychloride radicals meet some ozone? They make oxygen! Oh no, now all of our ozone is turning into oxygen, and we've regenerated the chlorine radical. So this is a catalytic cycle is the term for it, right? What we've done is it's just constantly converting back and forth between the chlorine radical and the oxygen chlorine radical, and the 2 steps are destroying ozone and stop ozone from forming. So we're burning the ozone layer. It's very bad and very sad, and we have to go ban them. But yeah, this is called a catalytic cycle. We'll see another one in a little bit. Hint. But that's the idea: is you have some part of your reaction, something that's basically regenerated as soon as you're done. And so that's what made the ozone layer thing so bad, is you could put a couple of chlorine radicals, and they could just keep going and doing the cycle over and over again, and destroying oodles and oodles of ozone, and destroying oodles and oodles of oxygen radicals too, which prevents ozone from forming. So, yeah, it's very bad. Thankfully, we banned them now. This is the reaction as a whole. You can see it's catalytic because the chloride radical, sorry, not an ion. The chloride radical is catalytic because it appears at like the very beginning and the end. And we're just making a bad time. So here's a question. Here's a question. Does this just go on forever? Are we that cooked? Does this just keep on going forever and ever? The answer is no, because if two chlorine radicals meet with each other, well then they can just, kiss, and we get chlorine urea. We get just the ordinary Cl2 chlorine atom, the toxic gas. It's still not great, but it's, and UV, the thing is that UV can break this apart again into generating chlorine radicals, but this is a termination reaction. So this is how radical reactions end, right? We start with initiation reaction, which created a pair of radicals, and we end with the termination reaction, where pairs of radicals come together. So this is sort of the general form, right? We start by splitting something up to get radicals, that's initiation. Then some stuff happens which preserves the radicalness, right? We're not where you have a radical plus something that isn't a radical, makes a new radical and a new something that isn't a radical. And then two radicals can combine together to make it not a radical, and that's our termination reaction. Hopefully that's not too confusing. These are the steps: initiation, propagation, and termination. And that's basically that's all of radical chemistry, actually. So congratulations, you now know all of radical chemistry. Definitely not. I didn't even talk about how bromine is worse, or why bromine is worse, but that's okay. It's a quick overview for a little YouTube video. All right, now we have to actually talk about HO2, because that's the whole point of this, the silly thing that seems like H2O, right? We have to talk about HO2 and what it's used for, and the answer is something called Fenton chemistry, or Fenton chemistry. Maybe I should have looked that up before doing this stream. Moving on. Okay. We have one last little intro chem concept to clarify, which is oxidation states. So generally, something like oxygen has a oxidation state of like 2-, which means it's always bonded to two things, or like by one double bond, right? The point is there's like, you can think of it like there's two bonds coming out of it. Some metals, a lot of metals actually, but sometimes you can have different oxidation states of the same atom. So iron, you can think of it like iron can bond, two things. You can have two bonds coming out of it, or 3 bonds coming out of it. That's the simplest way to look at it. But these are different oxidation states of that element. And so we have iron 2+ and iron 3+. And the fact that you can convert between these oxidation states and stuff is going to be important in just a sec, once my computer decides to not be stupid. I don't know if you can hear the fan screaming in the background. I don't know what's going on. It has not done this before, except when I've tried to use the other streaming app. But I'm not using the other model. Streaming is confusing sometimes. Okay. All right. What happens if we take iron 2+, a source of iron 2+, and again, iron 2+ wants to lose electrons. Iron 3+ wants to gain electrons. We'll talk about that in a little bit. Again, like I'm using this loosely, wants is not really how it works, but we'll get there. What happens if we take some iron 2+ and we mix it with some hydrogen peroxide? Well, if this were to split up like this into two, hydroxide radicals, well, we can donate an electron to one of those, and now we have a hydroxide ion. Here's our hydroxide ion. And we have a hydroxyl radical, because we only donated one electron, right? We could only one of them could have the privilege of not being a radical. So we've generated a hydroxide ion, which is interesting, but what's really interesting is we've now generated a hydroxide radical. And again, this is kind of breaking the traditional formula of like initiation reactions, because we're not really having something that's like, we're not having something break apart into two radicals. We're using oxidation states instead. So you can see we've gone from iron 2+ to iron 3+, because it's lost an electron. All right, so we've done that. Now, in comes another molecule of hydrogen peroxide. What happens now? Well, if the iron 3+ wants to take electrons, which will turn it back into iron 2+. So it accepts electrons. Well, if we were to break it apart here, we would see that, oh ho ho, we can take an electron off of this little guy, off of this hydrogen here. So this time we're doing the opposite of what we did with the hydroxide ion. We're removing an electron, making it a positive ion. So this is now H+. This is literally just like a standalone proton. Technically it's not. It forms H3O+. Yes, I know, but please don't fight me about it. I know it. Okay, that aside. Disclaimer about the fact that it's not actually a free proton aside. We'll pretend that once we turn this into an ion, we get H+. We get this free... It's close enough to a free proton. And we have an ion, we have an H+ ion, and we have, oh look, there it is, there's our hydroperoxyl radical. We made HO2. And what's so important about making HO2 is, we regenerated our iron 2+. Looks like a catalytic cycle to me. And it is. The iron 2+ is catalytic in this case. So what we're doing here, if I go do some questionable stop motion animation here, oh, look at this. We have our positive ion and we have our negative ion. If they decide to come together, we get water. So, what we've done here is iron 2+ has catalyzed the decomposition of hydrogen peroxide into water, a hydroxyl radical, and a hydroperoxyl radical. So, the first step made a hydroxyl radical, which is generally the more important part of this, because what people actually use this reagent for, what people actually do with this is like cleaning up oil and stuff, because the hydroxyl radical turns out to be really, really good at, like, again, radicals are like malignant agents of chaos. The hydroxyl radical turns out to be really good at breaking down organic stuff and just getting in there and screwing stuff up. The hydroperoxyl step is really important because it's what makes it catalytic. If we didn't have this other step, we would need to put in heaps and heaps of iron, and then it would get turned into iron 3 and it would just be used up. But the step with that generates the hydroperoxyl will regenerate the iron 2+. So we don't really need that much iron 2+. All right. Yeah, so it's a catalyst. I should have clicked to the next slide before that. Whatever. This is preparedness. For me, this is preparedness. Hopefully that was a helpful demonstration. I should check chat. Poor iron keeps losing electrons. Well, it gains them back, right? It alternates back and forth between gaining and losing electrons as it switches back and forth between iron 3+ and 2+ and 3+ and 2+ and 3+ and 2+. That's the catalytic cycle. And this like whole mixture is called Fenton's reagent. All right. Hello, Farbin. Hello, Farbin. All right. Now it is time. It is time. Time for what, you say? Well, time to actually make Fenton's reagent in real life. Heck yeah, I have, no, that's not what I meant to do. Slides. Camera, there we go. I have a bucket. I has a bucket. It's the meme with the seal. Why didn't I think of that beforehand? Oh no, I'm not, okay, it's okay. See, I has a bucket. It's this, except nobody be stealing my bucket. Why can't I do this? Why am I so bad at streaming? There we go. Slides. There we go. It's this. I has a bucket. I has a bucket. I really should have put that in the slides or something. Oh well. I has a bucket. Here's my bucket. Oh my gosh. Okay. So, let me move over to the side of my dorm room that hatheth the bucket. Hello, it's bucket time. Alright. This is far from an ideal setup, but if it works, it works. Alright. If it works, it works. Alright. So what I need to do is get the different reagents we are using. Wonk. Wait. You. Alright. The different reagents that we are using. Dear God, I know. Okay, I know. Oh, hi, Farax. You made it just in time for the start of the freaking fun demo part. Alright. Alrighty. So, the first thing that we will need is copper sulfate, which I got from Home Depot as this frickin' root killer stuff. Copper sulfate doesn't seem very helpful to us. That's not iron. That's not iron 2+. That's not what we need. Well, I also have some steel wool, which should contain iron. And what happens? What happens when we? Let me Okay, wait. I had a very funny thing for this, and I also forgot to put it in the slides because I'm bad at everything. Is it this? No, not that. I'm being silly. Okay, well, I'm just gonna recreate it. It's the distracted boyfriend reaction. That's what I've taken to calling it. It's no, frick you. I'm so good at streaming. It's this, all right. This is goodbye bucket. Yeah, this is what's gonna happen. This is what's gonna happen. The copper sulfate, right? We start with copper sulfate. When we add iron, the iron is gonna be. It's more favorable for the iron to bond with the sulfate. It's a more reactive metal, so the copper will just come out of solution as just copper particles, and we'll have iron sulfate. And iron sulfate, well, that's that solution will have iron in its 2+ oxidation state, which is exactly what we want. Yay! All right. So then the other thing we need is hydrogen peroxide, of course. And now this bucket is great and all. This bucket is cool. I love myself a good bucket. But there's another bucket from yesterday that I want to show you, and it's the bucket of shame. Are you ready to see the bucket of shame? This right here is the bucket of shame. Because before we actually make it, I gotta tell you guys about me being an idiot. On the Discord, you'll know, I said this stream was delayed by me being an idiot. In the thumbnail, there's an arrow pointing to me, and it says idiot. And that is correct. I am an idiot. What I was trying to do, and failed to do, was... His problem was with the steel wool. If this steel wool were to be stainless steel wool, that stainless steel is generally an alloy that contains iron, which we want, carbon, which doesn't matter, it'll just come out, and chromium. Chromium is like iron. We'll get another distracted boyfriend reaction, and we'll get chromium sulfate. So we'll be like chromium 2 sulfate. Air will immediately oxidize that to chromium 3 sulfate. And hydrogen peroxide in basic conditions, and it's possible. I don't know how likely it is, but it's possible. And I found some papers suggesting this does actually happen with like hydroxyl radicals. It's possible that we oxidize it even further. Remember oxidation states? We went from the air was able to oxidize chromium 2 to chromium 3. But we run the risk of oxidizing chromium all the way to chromium 6, which is a very, very nasty carcinogen and not something I want to make in not a fume hood. It would be very bad. I really don't want to accidentally make some super dangerous carcinogens. That would be very bad. So I was like trying to come up with a way that I can afford or use what I have lying around to like see, is there chromium in the steel? Because it doesn't say anything. There's nothing on the freaking label. No one says what kind of steel they use to make steel wool. So I'm wondering, like, I'm trying to come up with a test for chromium. I try. This is the bucket of shame. This is me trying to test for chromium using carbonate, and it doesn't work at all because it turns out to also test for copper. And remember, I started with copper sulfate, so there's going to be heaps of copper in there. It didn't work at all, but here's why I'm proceeding in spite of the basket of shame. The bucket of shame. It's the bucket of shame. I has a bucket. Why am I proceeding? Regardless, because if I had have read like 3 lines down on Wikipedia, iron sulfate, the main thing that I'm actually making, can actually reduces chromium from its 6+, its dangerous carcinogenic 6+ state to its normal, not so nasty 3+ state. The thing I'm actually trying to make will immediately destroy the, hexavalent chromium that I was so worried about making. And it was there. That's on like freaking Wikipedia the whole time. So yeah, that's what I meant by me being an idiot. But it's time now. It's time to make some frickin' Fenton's reagent. And I realized in all of my preparedness with slides that I am actually not prepared at all because I need to go get a glass of water. So let me go get a glass of water. Actually, before I do that, I don't know if you noticed, but I don't have actual glassware, so I used like these like spice jars, these glass spice jars that I got for like $1 a pop or something. Maybe it's $2 at frickin' like Target. but I found something better today when I went to get more ones because I would rather spend $2 instead of I would much rather spend $2 than I would go cleaning out these things in a rush before the stream. And I don't know, I'll clean it out eventually, but it's really hard to do chemistry with only two only two vessels anyway. So see, they're basically just giant test tubes. I don't know what I'm okay. I'm gonna go fill these up with water and just wallow in shame now. But yeah, that's what's going on. No, this is such bullshit. This is such bullshit. I present Wooder. Alright. Oh, I didn't even say what we're doing with the Fenton's reagent. What are we doing with the Fenton's reagent? Well equipped for basement science. Exactly. If only... look, I'm on the first floor technically, but we can qualify this as basement science. Yes, only the most professional of chemistry equipment. Indeed. It's glass. Ignore the fact that it's not borosilicate glass, but because I don't actually need to heat anything up here, so we should be good. We should be good. Okay, but what I'm actually doing with the Fenton's reagent, do I have a way to know that Fenton's reagent is being Fenton's reagent? Single-use glass are a poor chemist's best friend. I mean, hopefully it's not single-use. Hopefully eventually I'll go clean it up, but, you know, $1, $2, I can... Right now, it's enough. I can eat that. That's about all I can eat, but I can eat it. Okay, but what are we actually doing? Well, if you've ever seen a highlighter under UV light, you'll know that highlighters contain a dye, probably fluorescein. I'm not really sure. There's another one, like it's not pyridine, purine or something. I forget the name of the other one. So this might not actually be fluorescein. That's why on the side it says fluorescein spelled wrong. IDK. It's whatever is in highlighters. But yeah, so I took apart a highlighter, put the thing in water, and it does glow under UV, so it looks like fluorescein. It's probably fluorescein, but regardless, whatever UV dye it is, Fenton's reagent will create radicals. Free radicals will be malignant agents of chaos that they are, and it should be less fluorescent as the fluorescein or whatever it is gets destroyed by Fenton's reagent. That's the plan. And so I do have a UV flashlight. That's not UV. There we go. That's UV. It's not the brightest UV flashlight in the world. It's what I could get for a couple bucks at Home Depot. You might be noticing a theme about the way that I do chemistry. Phosphorescent is the other one you mean, I believe. There's yes. Fluorescence and phosphorescence are like the two common ones. Fluorescence is when it releases light immediately. Phosphorescence is when there's a delay. But what I meant is there's actually another dye. So not all highlighters contain fluorescein. Some of them contain a different dye, which does more or less the same thing. And so in theory, it should do more or less the same thing under Fenton's reagent. I don't really know. We'll. The thing is, I have no way to know if this is actually fluorescein or whatever the other dye is called. So, yeah, we'll see how this goes. But now, I gotta put some gloves on. It's gloves time. I'm almost out of gloves, but maybe everything will be fine. Oh, okay, yeah. You're not wrong that phosphorescence is a cousin of fluorescence. But yeah, that's not what I meant. All good. All right, it's gloves time. Gloves time. Am I gonna have to? I should maybe turn off the lights if I want to do the UV stuff at the end. I don't have to take gloves off and on back on again. Let's do that. Let me see. Maybe it'll be impossible to see anything, but yeah, I'll do it after. I'll do it after. All right. All right. Yeah. I meant the diet self. You got it. All right. We have water now. Oh, I should put safety goggles on. I wonder if it'll be able to track my model if I have safety goggles on. Let's find out. This is the real experiment here. We're not actually trying to see if we can make Fenton's region. We're trying to see, can OpenLive 3D track my... It can. Even my eyes? What if I close them? Kind of. It's not great, but I can kind of do it. Okay. All right. So first step is making iron sulfate with the distracted boyfriend reaction. So, got our copper sulfate here. I should maybe pour this into something else. Yeah, it'll be fine. Everything will be fine. That's why I have the bucket. The bucket is so that I can spill shit. Alright. Actually, if I'm going to do one of these with Fenton's region and one of them without, then I should probably make it somewhat comparable. How do I want to do this? Or do I want to add hydrogen peroxide? Because hydrogen peroxide blocks it. Yeah, let's do it this way. Let's do it this way. Consistency. All right, we're doing very real science here. Let me dig through my bucket of shame and get my graduated cylinder advanced scientific mitt. Do I really want to use this? This is awful. No, I'm not doing it. I would rather do bad science than have to do... Oh, okay, fine. I'll do good science and actually measure it out. Frickin'... I have to open the thing again. Oh no. I can't just be lazy. This is not a stable work surface. Everything will be fine. It'll work out. Okay. Let's measure out some number of milliliters. Again, this is the stupid American side. This is the cool European side, but it's also the science side. We have to use the science side. Let's do frickin' I don't know what I'm doing. Let's do 50 mils. 50 mils seems enough. Again, this is a solid crystal. You should not measure it with volume. It's just okay. There's a little bit of a story here too. The story here is that I went to this Target because online it said there was a scale for like $10. I was like, okay, I will use a scale a bajillion times before it dies. I can spend $10 on a scale. Then I go to the store and it's $20, and you have to wait like another day for them to do the pickup at the store or something. I don't know why it's that much more expensive. I'd almost understand if it was like $1, but no, it's like twice the price. I don't know why, so I just didn't get it and I just gave up, and we're not going to be consistent at all, but that's 50 milliliters. Yeah, sure. All right. Science. Anyway, this is our copper sulfate root killer. Can I not? There we go. I put the lid on, right? I can do chemistry. I can't do chemistry. Don't listen to me. All right. So what we'll do is we'll make iron sulfate in both of these, and then we'll add hydrogen peroxide, and so we'll make iron sulfate in both of these. We'll put in the highlighter dye in both of these, and then we will only add hydrogen peroxide to one. So hopefully one of them should have fluorescence, the other one should have a lot less fluorescence, and I don't know, should bubble and stuff too. Let's pour this in. This is why we have the bucket. We love the bucket. Because God knows where I would be without the bucket. Bad. I would be bad. It would be bad. Everything would be bad. Alright, so there we go. It's dissolving. It's dissolving. That's way too much. I made a mistake. Surely nothing will go wrong making evil water with stuff bought from local stores. Yeah. I feel I've made a mistake because this is... I literally did the exact same thing yesterday. It's like, the Einstein quote or whatever. I don't know if it's actually Einstein. It's like, the definition of stupidity is doing the same thing over and over again and expecting different results. I did the same thing yesterday. I put in way too much copper sulfate. So now I have to figure out how to get rid of it. Not get rid of it. There's no Riz on this stream, unfortunately. I do not have Riz. let's, I don't want to redo this all. That would be lame and sad. Let's do it this way. Actually, maybe it's fine. Maybe everything is fine. Because the copper sulfate shouldn't harm anything. Right? It'll just be there. It's sad that I'm burning through 4,000 times more copper sulfate than I actually should be, but I wasted heaps of it yesterday too, so we're kind of we're far gone on that. All right. Let's make the other one. Consistency. Try see if I can spill less of it. Yeah, science. I should note that copper sulfate is actually you can do lots of cool projects and stuff with it. So if you put something like iron in it, sure, you'll get iron sulfate in solution, but you'll also get copper metal to precipitate out. So you can, coat things with copper with it. Actually, you don't even need the other metal to coat things with copper. You can use electrolysis, but you can use it to coat things with copper or even just get copper metal. It's a cool way to get copper metal. There's a Hyperspace Pirate had a video about that. And you can also grow really nice crystals about it. Really nice crystals with it. So when I did the bucket of shame, the bucket of shame, I actually did it outside with a friend, and it was super fun, doing freaking chemistry outside with a friend. And he was a good sport about it too. Oh shit. Okay. But that did mean that we were, just on a picnic table in the middle of, there were like people walking by and stuff who were just like looking at us doing chemistry with beautiful blue crystals. It was perfect. It's perfect. Okay. Let me pour in this other one. This is not ideal. Yeah, again, this is way too much copper sulfate, but that's actually consistency. I spilled a bunch on the first one. To be consistent, I have to spill a bunch on the second one too. I'm doing good science here. God damn it. This is my plan for getting people to keep watching my streams. My plan for viewer retention is the idea of it's hard to look away from a burning bus or a car accident. That's my plan for getting people to stay engaged watching my streams. I get to do the science equivalent of a freaking car wreck. Exactly. It's the plan. It might not look according to plan, but it is. It is. All right. Now let's go ahead and add some steel wool. And one of the cool things is this is when chemistry actually looks like you expect it to look like, and you have liquids changing colors. So copper sulfate is blue, but ferrous sulfate, iron sulfate, how do we even find out stuff like that? Is this the one where it explodes? Stay tuned. Yeah, I do want to test an explosive thingy at some point. There's a really, really sensitive explosive that people mostly just use for goofing around called touch powder or nitrogen triiodide. It's not really powerful or anything. It's just it's one gimmick is that it's really, really sensitive. So you can tap it with a stick and it'll it's guaranteed to explode. But some people online, and this is a very debated point, say that it's so sensitive that alpha radiation, radiation, the same kind that the sources in smoke detectors make, alpha radiation can actually cause it to detonate. So I want to try that. I want to try detonating nitrogen triiodide with alpha radiation because it doesn't seem like it should work. There's lots of people who say that it doesn't actually work, and it would be, but I haven't found that many, I haven't really found a YouTube video actually testing it. Maybe there is, that is out there, but I think it'd be a fun thing to try to test because I have alpha sources. But is your UV powerful enough? Flashlights are often just UVA. I'm not using UV to do any radical reactions. You can. There's a variant called the photofenton reaction, where it's a UV-assisted version of the Fenton reaction. Oh, that sounds cool. Yeah, it would be a really cool video, I think. So I'm not using UV to do an actual radical reaction. There is absolutely no way the dinky Home Depot UV flashlight would be able to do radical reactions. The only reason the UV is... Yeah, the Wikipedia... Right, Wikipedia says it. But then I go try to find, other sources. There's lots of other sources that say it doesn't. Or, a couple other places where people say it doesn't. Yeah. So I'm not trying to do it. The only reason I have the UV is to see if the highlighter dye is still, fluorescent. Because, in theory, Fenton's reagent should destroy the fluorescence, or to destroy the fluorescing chemical. Yeah. That would be fun to do. I want to do that. Okay, what am I doing next? Next, we need... Should I be touching this with gloves? Oh well. We need some steel wool. Some yummy, delicious steel wool. That can go in the bucket of shame, sure. Alright, so I'll try to split this more or less equally in half. Yeah, no, I do think it'd be interesting. Even if it doesn't work, like, it'd still be cool to see. Because I'd be very surprised if it's... I really don't think it's like you can hold a, weak alpha source next to it and then it will immediately detonate. But what I could do is, make a bunch of batches and see if just the time to detonate from it just, like, sitting there. Because sometimes if you just leave it to sit there, it will detonate eventually, right? So I could see if there's, a statistical difference between just sitting there versus with alpha radiation. That's my guess of how I do it. Oh, I can split it like this. Whee! Yeah, so this is steel wool. It probably doesn't contain chromium. Again, like the whole chromium saga was out of an abundance of caution. Because making chromium would be very, very bad. Making chromium-6 would be very bad. Thankfully, it would not be very bad, actually, because the iron sulfate would reduce it. But, yeah, so what we should see here, if I put it in, we'll see a color change. Again, steel wool, this will go way faster than with, like, ordinary, just a random hunk of steel, because you have so much more surface area. That's why I wanted to use steel wool. But we should see a color change to green, because iron sulfate is green. And we should see a bunch of copper metal come out of solution. So it'll look like rust on the... Yeah, it's funny you say making poison, because I'm actually unmaking poison. Copper sulfate, like in pesticide form, is actually, quite it's fairly toxic by, like, ingestion and stuff. It's not hydrofluoric acid or something crazy. It's really not that bad. It's fine for consumer products and stuff. But it is, orally quite toxic. When I make iron sulfate, is actually a lot less toxic. So I'm actually unmaking poison, which is quite a rarity for chemistry. Normally you just take things and make them more poisonous, and that's your paper. Yeah, so let's see. So we should see it turning green by making iron sulfate, and we should see copper particles. It'll look almost like rust. They'll absorb onto the actual steel wool. Which I should have put less water in, but whatever. I should have put less of everything in. Whatever. Let's see. There we go. Oh, now my gloves are really cooked. Oh well. So, I just realized I can't really easily show this off to the camera. There we go. So it's a little bit of a different color, you can see. It was a lot bluer before. Now it's more... Try not to freaking spill it. That would be bad. Now it's a lot more green. That green is our ferrous sulfate. So iron 2+. And the whole thing is just FeSO4. And if I pull this, I don't know, let's give it a bit more time. Soon you'll be able to see the actual copper particles. And I can pull this out. You can kind of see it on the bottom. There we go, actually. Alright, so I don't know, let me see if... You see that layer of, like, freaking, like, brown stuff? That's not rust or anything. That's tiny copper particles. So we've got... Our bottom layer is a bunch of excess copper sulfate, because I keep doing that because I'm an idiot. Then we have our layer of just copper powder, and then above here, this green stuff is ferrous sulfate. So yeah, there we go. There we frickin' go. Alright. Is it not focusing? Focus, you dipshit camera. It's actually just my phone. I couldn't... Normally, when I need a webcam, I can go get them from, like, the library at our uni. But uni library is closed because it's the first day of frickin' spring break. Actually, you know what? Well, this goes. I can talk all about that. Because the reason the stream is today and not, yesterday, is because of the chromium saga. I like that. But the reason the stream was like 10 minutes later or whatever is because I forgot that it's spring break and of course the library will be closed. So I go, we have like a bike share program where you can there's like stations, like a ride sharing bike program thingy. So I go to the station to go get a bike, to go to the library to go get camera, and there's someone else there. There's 3 bikes there. One of them, the app is kind of stupid and jank. One of them, for either of us, the app says it doesn't exist, and the other one, so there's 2 bikes here and there's 2 people. He can't check out bikes though, and you can only check out like one at a time. So I get my bike. He's like, I'm like, hey, do you want to just use this one? And he's like, no, it's fine. I'm just going, back to my flat. It's not that far away. And so I'm like, okay. And I go to the library. I realize I'm a freaking idiot. The library is closed. It's spring break. But he's like on the same direction. Yeah, the fan can be heard. At least Yep, that's the fan, but I would rather... Ventilation is more important than audio quality. Yeah. But so I'm... Like, his flat is the same direction as the library. So I put the bike down, and I see him over there. So I just check out a bike, and I'm like, hey, just use this bike. If you can't, your app is freaking broken. If that's all carked, then just use this bike that I just checked out. I don't need... So I do, and I gave him the bike, and then I walked back. And that's why the stream was late. So it was late due to me being an idiot and forgetting that the library would be freaking closed. But it was actually good because I helped some random stranger get back to their flat without having to walk all the way. So, you know what? It worked out. It worked out. Yeah. There we go. This one you can see a lot of copper. Right? It's all brown. I'm not spilling that, am I? That's cool. All right. So let's take most of the steel wool out. I might leave a little bit just because copper... It's going to keep generating copper sulfate because I was dumb and have a bunch of excess at the bottom. So it would be nice if we could, not waste that and turn it into... There we go. Bullshit. So, yeah, I don't know. My camera will decide to focus. It does look a lot like rust, but it's not. It's copper. And then this one should have... Oh, look at that. That is heaps of copper right there. Heaps of copper. I'll go take this one out too. Maybe I should take them out in the other order. Whatever. Yeah, look at that. Can I just pull it up and show it up? Yeah, so that sludge right there, that's a bunch of tiny copper particles. Pretty cool. In any case, this is the wildest combination of streaming genres. I'm going to take that as a freaking compliment. Yeah, I do also do coding stuff. I haven't in a long time, but I'm working on a big project. It involves Twitter, and I don't like Twitter, so I'm taking matters into my own hands, and it's very silly and ridiculous, and I'm super excited about. That'll probably be a video. Although I might do like a stream related to it. That's a much bigger long-term project that I'm working on though. But yeah, no, the chemistry, frickin' science VTubers, rise up. There are actually a couple of good science VTubers. All right, so that right there is some lovely green ferrous sulfate. So we've got iron 2+ in solution. Now we need to add the frickin' highlighter dye, and then we'll add hydrogen peroxide to one of them, and that will... The hydrogen peroxide will make Fenton's reagent, which should destroy the fluorescence of the highlighter dye. So let me change gloves. Change gloves. My hands are so sweaty. Sweaty. What I can also do now... That's not copper sulfate on my keyboard, is it? That would be bad. Chat, did I spill pesticides on my keyboard? Okay, well, I'll try not to touch it. This is not how you should be doing this. Okay, what was I gonna do? I was gonna do something clever. Oh yeah, I was gonna move me to the other side so that the direction I'm looking lines up with the direction that the thing is. There we go. So now if I go look at the reaction, hey look, it looks like I'm actually looking at the reaction. It's perfect. I know how to stream. It's still out of fucking focus. Focus, you dipshit. Oh, my God. I can't do that. Will that get it to focus? Whatever. What frickin' ever. Oh no, the bucket has failed. Yeah, did I touch it? No, I did. I mean, it's not the bucket that failed, it's me using the bucket. It's fine. I mean, it's like, it'll kill you if you, like, eat it, but we'll be okay, we'll be okay. Yeah, generally, this is not an ideal setup for chemistry. I can definitely say that much. Okay, highlighter dye, right, highlighter dye. Let me actually make sure it's UV. Let me turn off the lights. Let me freaking turn off the lights. It's a little bit darker. Hey, it being darker kind of hides the fact that it's out of focus. Does it? Maybe a little bit? Okay. Let's get the lovely highlighter dye. There we go. There's our it's just been sitting for, days, and this is just water. Supposedly you can get better extractions with rubbing alcohol, which, I mean, I have isopropyl all over there, but I didn't want to bother. So there's it under regular light, and under UV light, hopefully this looks cool. Whoa, glowy! Let me do less of it. Yay! Again, maybe it looks... It's hard to get it. What if I... Can I do that? There we go. That's what it looks like to me. That's what it looks like to me. It looks so cool. It's glowy. It glowy. It glowy. Alright. Now let's see if we can make it not glowy with the power of misspelled water. Somebody... No, don't steal my bucket. Actually, do steal my bucket. It is right now, the bucket of shame, at least, is nothing more than a liability of corrosive waste. Please, I would love for you to steal my bucket. Alright. Now, in theory, the correct thing to do here would be to use the measuring jug to pour it out. But what if, cue the Vsauce music, I didn't, and just poured? Let's do that. I'm feeling like it's a that kind of stream. So we'll just bring them up to the same water level. They were at the same level before. And maybe spray highlighter dye all over. That's okay. I'm fine spraying highlighter dye all over. That's pretty much non-toxic. Turning my college dorm into a radioactive super fun site. Okay. Yes, I have done. You just go to my channel. You can see the last, not the last video, but actually, yeah, the last video that I did was the antimatter one. I did nuclear reactions in my dorm room. Technically, look, if I did nuclear reactions, I made a thing that does nuclear reactions, it counts as a nuclear reactor. That's the plan. And I do actually have another... Probably. So, tomorrow, I will probably be doing another chem stream, because it's spring break, but I'm at the dorm, and so I don't have to deal with parents breathing down my neck, and so I think I just can. That will involve radiation. Not making radiation. I don't want to give too many hints. It'll involve... If that works out, it will involve radiation. Alright, let me... That's that. Let me get the freaking UV flashlight. They glowy! We got the glowy! And they are actually glowing about the same amount. So that's good. We did good science. I poured in about the same amount. That's good. That's cool. Things that glow are cool. Fluorescence is cool. Phosphorescence is cool. Yeah, look at that. Look at that. Alright. Let me put gloves back on, and then we'll add some hydrogen peroxide and see if we actually can make Fenton's reagent. Freaking gloves. I need to buy more gloves. Alright. Oh no, you were constantly watching it 20 minutes late. No. That's alright. Well, I can catch you up then. What I now have is two identical frickin' champagne glasses from Target filled with iron sulfate and highlighter dye. And you came frickin' just in time. Just in time. Oh, wait, shit. Is that gonna... I can do it this way. Yeah, you came just in time for the addition of hydrogen peroxide to one of them, which will hopefully form Fenton's reagent and destroy the highlighter dye through making hydroxyl and hydroperoxyl. Of course, hydroperoxyl is the main goal of this because I think it's funny, and I need to atone for my sins. I need to atone for my sin of misspelling it. And my laptop is dying. Do I get the charger or just do this fast? I'm thinking just do this fast. Actually, I'll get the charger. I'll do the correct thing for once in my messed up life. I'll get the charger. Freaking frick shit. Do I take off these gloves? I should take off these gloves. I'll take off one of them. Whee! Fly, glove. Fly like the wind. Alright. Achievement unlocked. Acquire the charger that you should have had in this corner of your dorm room the whole time. Work. And this gets plugged in. Do not. Frickin' frick. It's almost like this is not an ideal setup to do almost anything, but we press on. Okay, come on. No, don't go in the bucket. I didn't get copper sulfate on my charger too, did I? No, it doesn't look like it. I don't see any blue. Is that because there's no blue or because the lights are off? I don't know, but I'm going to plug it in anyway, and we'll just pray. It's probably fine. She'll be right. Oh, hi! Hi! Zed! I'm gonna keep saying Zed. Hi, Syzygy, though. I'm so glad to be black streaming. This is such a crazy idea for a stream. I wanted to do this for a while, as soon as I found out that HO2 was a real thing. I can only stop by super briefly, but wanted to say hi, and hope it's going well. It is going well. Thank you so much for saying hi. And if you're still here, thank you for being such an awesome inspiration and really inspiring me to do VTubing and stuff. It's been great, and thank you so much for the role that you've played in that. And everyone else, go watch Syzygy. Go subscribe, subscribbles. Go watch Syzygy. You have a bucket to make sure nothing gets anywhere. I'm spilling. Look, the bucket is a way more of a mess than the other stuff. I didn't actually spill copper sulfate on the charger. There's just a couple tiny flakes of it, or what looked like it might be it on the keyboard. Yes, thank you for the kind of words. Thank you, and go subscribbles. Syzygy just made like the start of a PDE course, which is awesome, and I think I put this in Discord, but having to suffer through freaking USSR textbooks to learn PDEs, this is worlds and worlds better. So go check that out. All right, it's HO2 time. Let's do this. Wait, I need another glove. I don't want to do this with only one glove. It is not good safety practice. All right. Do I have the technique of putting on a glove with a glove on? I got the technique. The technique. Frickin' get in there. Get on in there. Talk to it. No, that doesn't even work. All right. That's not really good enough, but there we go. All right. Let's add some frickin' drugstore grade hydrogen peroxide and see what happens. I don't really know how much to add because it's catalytic anyway. So since it's catalytic and we have oodles and oodles of it, all of this should dissolve. Let's see. Oh, it's doing something. It's turning brown. that might be it breaking down stuff. It's making me wish I hadn't overfilled this so much. But can I set that down? Where can I set this down? I'll set it down here. It did something. Did we make Fenton's reagent? Did it worky? Seems like I made it just in time to see the action. You did. So we're trying to make something called Fenton's reagent, which is when iron 2 reacts with hydrogen peroxide. And so over here, we have just iron 2 sulfate and some highlighter dye. Here we have iron 2 sulfate, hydrogen peroxide, and some highlighter dye. So the reaction of iron 2 sulfate and hydrogen peroxide is what it looks like it be doing. It looks like it's working. It's generating radicals, which are, the brown is good, I think. That's what we want to see. We want to see it decomposing the highlighter dye. And generally, decomposing anything organic will give you shit-colored junk that looks horrible. But so the reaction is doing is generating HO and HO2, which are radicals. They have unpaired electrons, they're super reactive, and they should break down the highlighter dye, which is it looks like what we see. And I don't know if you can, actually you kind of can. These glasses are like perfect because from above you can actually kind of see the spectrum, because I don't want to tilt it too much, but like look, you can see that we've gotten, most of it. There's like a layer about this. There's a layer of blue, which is the copper sulfate, because I put in way too much. There's this tiny little layer, which is the copper, but then the other layer you can see on the camera, the green layer, that's stuff that hasn't reacted yet. Most of it's all reacted. So it looks like we've done it, but to really test, to really see if we've destroyed the highlighter dye, if we destroyed our enemy, the fluorescent highlighter dye, and if I've ripped a hole in my glove trying to take it off, that's fine. It's fine. Haven't done that before. It's a new one. It's all right. It's not actually bad. Like ripping a hole in your glove when you haven't actually touched anything and it's fine and there's nothing on it is probably the best time to rip a hole in your glove. Now let's see. Has the fluorescence gone away? 3, 2, 1. That is very not fluorescent. Wow. I mean, I kind of could tell because it's green, but look at that. We've destroyed the fluorescent dye. Our enemy, the fluorescent dye, which was actually not our enemy because it looks cool, but it is our enemy because we're trying to destroy it. You just tried destroying your enemy. We destroyed both. The glove was a noble sacrifice in our conquest against the fluorescent highlighter dye. But so this Fenton's reagent, which creates HO and HO2, like the radicals, it's actually used not just for destroying highlighter dye, it's used for destroying things like oil and stuff. So it's used actually sometimes to clean up oil spills and, basically just in like wastewater treatment when you want to destroy, random organic junk. These radicals, since they have unpaired electrons, are very, very reactive, and so they will just chow through shit as you've seen them do. So that's good. That right there is solid. I'm so glad it actually worked. So that is, that's it. We made HO2. It's probably all terminated by the time this reaction is done, but the proof is in the pudding. We made some HO2 because I have finally atoned for my sin of misspelling H2O. So that's that. Hopefully y'all had a fun time. I don't think there's anything else other than the fact that I will probably be streaming tomorrow. And I will also probably be making a video. I'm not going to give too much away, but because the video is going to be like the main trailer. I'm not going to spoil a video, but there's a series, and if everything goes well, the first of that series will be a live stream tomorrow, and I'm really excited about that. But if you have any questions related to anything or basically anything. As long as it's decent, if you have any questions, I'm happy to answer them. I'm so glad that it actually worked. We made HO2. We made frickin' HO2. All right. Yeah. If that's the stream. So if there's nothing else in chat, nothing else that I can see, then I think we'll call it here. Thanks so much for everyone who hopped by. Thank you so much for getting to witness the destruction and the valiant fight against the highlighter dye with the power of radicals. All right, bye everyone, and thank you so much for. Oh wait, I have a thing to say. I came up with a thing to say. I will see you in no time. I will see you in no time. All right. I will see you in no time. Oh, thank you, Astral. Thank you. I'm glad you guys had fun. Oh, thank you, Astral. Thank you. I'm glad you guys had fun. Tomorrow, probably stream. Hopefully stream. Thank you guys so much for Oh, Firax, thank you, Firax. Yeah, thank you guys so much for stopping by. I really, really do appreciate it. I'll actually I'll